मतलब मैंने जाते जाते भी याद दिलाया था, फिर भी आप भूल गए। दैट इज नॉट अ गुड थिंग डियर, बिल्कुल भी अच्छी बात नहीं है। So everyone revision किया आप लोगों ने? Have you done the revision? Because motion is going to be, motion is going, like we are going to implement the motion as well in the force law, in laws of motion. Okay, so 3 equations of motion, the concept of rest and motion, all the things will be implemented in this chapter. Okay, so revision is a necessary thing to all of you. So which chapter is currently going on in your schools, बच्चों? Saad, which chapter is currently going on in your school?
Motion, sir. Motion, it finished.
अच्छा, motion.
Motion,
भारती,
it finished.
ठीक है.
The force and loss of motion.
Force, अच्छा ठीक है. How much part they have done so far?
So today we discussed the third law.
अच्छा, so almost half, more than half of the chapter, right? चलो ठीक है, like almost हम लोग सही टाइम पे चल रहे हैं स्कूल के अकॉर्डिंग. अनम, आपका what's your status of the school?
Sir, we just finished motion and we're about to start force and law of motion after the
अच्छा,
holiday.
चलो ठीक है, that's great, that's great. So it means that we are basically going parallel to the school syllabus. चलो, that's good. Arhan, what about you?
First chapter.
Yes,
First chapter.
first chapter motion. So it means that you are going ahead of your school. So
Summer holidays.
yes.
Summer holidays.
अच्छा, समर हॉलीडेज, चलो. सो कोई बात नहीं, थोड़ा सा फ्लेक्स वगैरह करना स्कूल ओपन होने के बाद. It means that you have already done 2 chapters. ठीक है. सारा, what about you?
Sir, the second chapter, force
Force
and laws
laws
of
of
motion.
motion. चलो ठीक है. राफे, what about you?
So we are still in motion.
अच्छा ठीक है. और हम?
We finished force and laws of motion.
ठीक है. हनन?
Doing force and laws of motion.
ठीक है. हैदर?
Sir, we finished force and laws of motion.
ठीक है. फुरकान?
Sir, force and loss.
चलो ठीक है. चलो. अरहम, राफे, हैदर, हनन. Please switch on your camera, बच्चों. हैदर? बस देखो, फेस टू फेस इंटरेक्शन होगा तभी आप लोगों को और ज्यादा उसमें इंटरेस्ट आएगा. अनलेस एंड अनटिल मैं बोलता रहूंगा, लाइक मेरी भी वीडियो ऑफ रहेगी, आपकी भी वीडियो ऑफ रहेगी. वो इमरजेंसी में मैं ऑफ रखता हूँ, लाइक इंटरनेट अनस्टेबल है या फिर तबीयत ठीक नहीं, दैट इज अनदर थिंग. बट मेजॉरिटी ऑफ द टाइम, सो जितना आप फेस टू फेस इंटरेक्ट करोगे, इट विल बी लाइक इन्वायरमेंट और उतना बेटर होगा. ठीक है, चलो. सो लाइक ऑलमोस्ट सभी बच्चे आ गए हैं. ठीक है, चलो स्टार्ट करते हैं. अच्छा, okay, so now the first thing that in this chapter we are going to discuss is about the force. Okay, okay, so I think somebody has joined again. Furqan, Rafe, Furqan. Okay, so one by one I would like to ask one thing. It's an open question to all of you. Okay, randomly I will ask some from anybody. What do you mean by force? What comes to your mind when you hear the force? Bharti?
Like a push or pull
चलो ठीक है.
on an object.
ठीक है. अनम? What do you understand by force? What? Please let me know, Anam.
Yes, sir. Force can be defined as push and pull or act that can change the shape, motion, and direction or speed of an object.
Yeah. Okay, that's good. Hanan?
Force is referred to as something you can pull, push.
Okay. Okay. So Furqan?
Sir, force means something is pushing or a type of.
So all of you gave the almost like a very good answer.
So the push and pull of an object.
Okay, that's good, Rafi. That's very good. Yeah. So basically, force is a thing, is a quantity that is basically. When I got answer in the header. Actually, ठीक है header. That's good. Chalo, that's good. Okay. So it's very good that all of you are responding in the class. That looks very good. Okay. So basically, force is nothing but is a kind of, you can say, force is a kind of action, or you can for basically force is a quantity which changes the shape of an object, or it can stops the motion of an object, or it can basically makes the object in the motion. It can basically start the motion of an object if the object is in rest. Okay. So it is a physical quantity, right? So it means that if it's a physical quantity, you will think that it should be visible, right? It should be visible. It should have some kind of shape. But instead of that, force cannot be seen. It's look like a ghost. But it is very it's very, you can say, we use this quantity in our daily day-to-day life, right? If I'm able to basically hold this pen, this is due to force, because with my hand, the force present between my fingers, and the pen is frictional force. Okay. So these are the things that we'll study. Chicken. So first of all, let's do the basic thing about the force, that is chicken. Just before that, I would like to tell you frame of reference, because frame of reference is important. Frame of reference, because in this chapter we are discussing the frame, we will be taking all the calculation according to frame of reference. Okay. So let me draw a diagram. Okay, so frame of reference पहले मैं diagram एक बना देता हूँ. Suppose this is a train. ठीक है. So okay. So यहाँ in this train. Sorry for the bad drawing, but थोड़ा manage कर लेना आप लोग. ठीक है. आर्ट्स में बहुत ज़्यादा बुरा हूँ. So Bharti and Sara are traveling in their train. Okay. So and suppose यहाँ पे आपके तो यहाँ पे this is किसको कभी मैंने चलो ये मैं कह देता हूँ. ठीक है, हैदर को ले लेते हैं. ठीक है, हैदर is standing at the platform. So it's a train going in this direction. Okay. So if a train is moving, it should have some velocity. Okay. So it is going in this direction. Okay. Heather is standing at the platform. So what Heather will observe when the train is moving? Anyone? What Heather will observe when the train is moving?
That the people sitting inside the train are moving.
Yeah, absolutely. It means that, yeah, absolutely right, Anna. It means that when the Heather is standing on a platform and he is observing that the train is moving, and the object and the person sitting in the train are also moving with the same velocity with which the train is moving. Yes or no? Yeah. It means that according to Heather, they are having some velocity v. Yes or no? Yes. Bharti and Sara are traveling. It means that according to Heather, they are traveling with the velocity v. Yes or no? Right? Okay.
Yes,
now, now change the scenario. Now let's get into the train. Bharti and Sara talking to each other. Suppose they are discussing the physics syllabus in the train as well. Okay. So what they will feel? Are they moving? If we see with the reference of Bharti and Sara, are they moving in the train?
No, sir.
So if you look from their point of view, they both are in rest.
They both are in rest. Arhan said and Anam said they both are in rest. Furqan, what about you? भारती, सारा, आप लोगों के बारे में बात चल रही है, so please respond. Yes, please tell me. Heather, Saad, Arham, what they will see, what they will observe when Bharti and Sara in the train, and I'm asking whether they are in rest or in motion. If we take
They are
the
in
frame of
rest.
reference, yeah. So it means that when, according to Bharti and Sara, what they will observe is that they are sitting in the train. Okay, they are like they're sitting in the train with no velocity, with zero velocity, right? So this is called frame of reference. Frame of reference, like if we change the frame of reference, this whole scenario changes. Okay, so that's why frame of reference, we will do all the calculation according to the frame of reference. That's why it is very important. It's not like it's not mandatory, but I just wanted to introduce this thing so that you can understand how do we proceed the calculations, right? Suppose that I'm sitting at my home and the earth is revolving. According to me, I'm sitting at the home on my we can say carpet, on my chair, like I'm at rest, right? But if an alien is seeing me, what they will observe is that I am in the motion, circular motion, right? Because they are seeing me from an exoplanet. Okay, so that is the difference. That makes a difference. So right now, if according to Heather, the velocity is v, but according to Bharti and Sara, the velocity is 0. So there is a big catch in this concept, right? So the calculations will become completely you can say different, right? Clear, bacho? Saad, Arhan, Anam, Heather,
Yes,
Bharti,
sir.
Hanan,
Yes, sir.
Furqan,
Yes,
Arham,
sir.
Rafe,
Yes.
Sara.
Yes, sir.
Okay?
Yes, sir.
Yes, sir.
Yeah. So that's why it is important to understand the frame of reference. So we will not go into the deep what kind of frame of reference do we have. I just wanted to tell you the definition, because sometimes somebody says this thing, what do you mean by frame of reference? You have done the force and laws of motion. So what do you mean by frame of reference? So you have to answer like this. So I'm going to write down the definition. So after a frame of reference consists of an abstract coordinate systems and the set of physical reference points that uniquely fix the coordinate system. And standardize the measurements with that frame, because measurement we will be taking according to the frame of reference. Okay. And standardize measurements. If I'm taking the frame of reference of Heather, so all the calculations will be based on the frame of reference that is in which the Heather is present. Okay. Measurements within that frame. Is my writing readable? Anything that is not clear, बच्चों?
No, sir.
चलो ठीक है. In that frame, like definition will not come into the exam, but this is just for the knowledge. But okay, because if you are doing something, so we should be conceptually right. Clear? The main thing is that. Okay, because okay. Now what we were doing the force. Okay. So now I can write down the. So a push. A pull on a body is called force. Okay. A push or pull on a body is called force. Okay. Force, the thing that we use in our day-to-day life is like you can say what I was saying, pushing, pulling, or you can say twisting, stretching. Okay, pressing. We press. Suppose if I'm pressing with my hand, so it is pressing. So these are the kinds of example that we use in our day-to-day life in the form of force. Okay. Are used in our everyday life. Like pushing, pulling, stretching, etc. Okay. These are the example of force. Clear, everyone? In
Yes.
doubt so far to anybody, please let me know.
No, sir.
Okay. Now let's discuss a little bit about the effects of forces on a body. What are the effects of forces on a body? Okay. So first of all, I've told you about that force cannot be seen, but it can be observed. Okay. So we cannot see the force, like it does not have any physical existence, right? So this is also important. Okay. So effects of just a moment. Sure. Effects of force. Okay. So first of all, I will let you know the force cannot be seen. We observe. Okay. So if you talk about the effects of forces, a force can move a stationary object, a force can stop a moving object. Okay. Force can change the direction of a moving object as well, and force can change the shape of an object as well. Suppose that you have a balloon. So if you press the balloon, what will happen? It will become distorted. Yes or no? Okay. And suppose that if you have a ball, you have seen cricket. How many of you have seen cricket? पसंद है सबको? ठीक है, चलो, that's good. India is in the semi-finals. ठीक है. So, so basically what we see is that when the ball is thrown by the bowler, the batsman having a bat is basically strikes the ball with a very great force, right? So what happens is that the ball is going in a straight direction, but as per the force applied by the batsman, the direction of the ball will change. It will go in another direction in which he has hit the ball. Okay. Yes or no? And when you slow down the hitting moment now of the ball, you will see that the ball will change its shape. It will become distorted due to the hitting power of the batsman, hitting force of the batsman, right? Clear? So in the single example, you have taken two options, like you have taken two effects, direction as well as the shape. Clear? Stationary body. Okay. Third is a force can change the yeah. And last one is force can change the shape of the body, shape of the object. Okay?
Size also.
Shape and size. Okay. So these are the effects of forces on a body, right? Clear, everyone? Please let me know. Please let me know.
Yes, sir.
Is there any doubt
Yes,
to
sir.
anybody? Bolo, bacho?
Yes.
Chalo, that's great. So if we talk about the very you can say generalized definition, that a push or pull is not a definition which you can write in the exam. Yes, you can write, but it not that is not a correct definition. That's a very general definition. Okay, let's do a little bit detailed definition of the force. That is that you can write in the exams. Okay. Can I take a 1 minute pause? Actually, it's Azan right now. But can I take a 1 minute pause? Thank you.
Yes, sir, no problem.
Okay, everyone. Thanks so much for waiting, Bacho. Okay, so let's do the definition. A force is an influence okay, which tends to set stationary body in motion. Or moving body, okay, or which tends to shape, which tends to change the and speed of a moving body or which tends to change the shape and size of a body. Okay. So this is a definition of force in which all the aspects are covered. ठीक है? बोलो बच्चों क्लियर है?
Yes, sir.
कोई डाउट किसी को?
No, sir.
श्योर? चलो ठीक। इसने लेफ्ट की एक मीटिंग। रहान है, अनम है, अरहम है, भारती है, हनन है, हैदर है, साद, रफे, फुरकान। फुरकान हैज लेफ्ट द मीटिंग। ठीक है चलो। ठीक है। सो ये आपकी फोर्स की डेफिनेशन है। क्लियर बच्चों? किसी को कोई डाउट यहाँ तक? एनीवन प्लीज लेट मी नो वंस।
No, sir, no doubts.
चलो ठीक। अब बात कर लेते हैं जरा दूसरे टॉपिक की जो अब हम स्टार्ट करेंगे। ये बेसिक सी चीजें थी, प्रॉपर्टीज थी फोर्स के बारे में। अभी डिटेल में और पढ़ेंगे फोर्स की यूनिट के बारे में, फोर्स किस टाइप की क्वांटिटी इन द सेकंड लॉ ऑफ मोशन, बिकॉज इन दैट पोर्शन फोर्स विल बी डिफाइंड एज अ फिजिकल क्वांटिटी। ठीक है, सेकंड लॉ ऑफ मोशन। ठीक है, सो राइट नाउ लेट्स डू बैलेंस्ड। Okay, balanced and unbalanced forces. So basically two types of force that we will discuss is balanced and unbalanced. So as you can suggest the types, or you can say characteristics of the force according to the name, that is balanced and unbalanced. So in the balanced forces, if I say in a very general manner, so it would be, so in the balanced forces, it means that all the forces are balanced. It means that the net force, the resultant force on the object will be zero. Clear? There will not be any you can say motion of an object due to the force. Clear? Say yes or no.
Yes.
Okay. And if we talk about the non-balanced force, it means that the net resultant force on the body is not zero. Okay. So this is the basic thing about the balanced force. Okay. So let's do about the balanced forces. Okay. Balanced force. So, okay, so balanced force means that if the resultant of all the forces acting body is zero, the forces are balanced forces. Clear, everyone? The forces are balanced forces if the resultant force is all the resultant of all the forces is zero. Clear? Bolo clear? Sure, that's good. Okay, so let me give you an example of the box. Okay, so as you can see, okay, as you can see, a box is lying on the ground. Okay, heavy box is lying on the ground. Okay, so what in this example you will see is that just you will see that here if the box is like lying on the floor without any movement. Okay, so what you will see, देखो, force of gravity is downwards because gravity attracts toward the surface. Bolo yes or no? This is known to everybody, yes or no?
Yes.
Okay. Okay. So box is lying here. Obviously, if the box is lying on the ground, it means that there would be some friction. If I'm applying the force in this direction, so same amount of force will be applied in this direction due to the frictional force. Okay. Right now, the box is not in the movement, in the motion. It means that my force is less than the frictional force that is between box and the object, box and the floor. Okay. That's why box is not. Okay. And this is force of gravity. Whatever is the force of gravity in the downwards direction, a force called normal reaction is in the upward direction. Like normal is not in your syllabus right now, but this is an example I'm giving you right now. Okay, so don't get confused. So it means that you can see all the forces are zero. This gravity force is getting cancelled by this force of reaction. Force of friction is cancelled by the force of push or pull. Bolo clear hai sabko? So all the resultant are zero. If we add all them up, they will cancel each other. Bolo yes or no?
Yes, sir.
Okay. So that's why, that's how you can say these forces are. Okay. These are balanced forces. And if we talk about the unbalanced forces, okay. Yes. From this you can conclude that if the forces are balanced, so it means that if the object is in motion, so it will remain in motion, and if the object is in rest, it will remain in rest, because all the forces are zero. Whatever is the motion present in that body is basically before applying the force. बोले सर, it's clear सबको ये बात?
Yes.
चलो, that's good. So A part I'm writing here. The balance forces act on the body. Okay. The body continues to be state of uniform motion. Is everything clear to all of you or no, Pacho?
Yes, sir.
Yes, sir.
Okay. So next thing about this is would be, so it means that through balance forces, so it means that balance forces cannot produce motion in a stationary object, or it cannot stop a moving object. Okay. They can only change the shape of an object, right? Suppose that if you have a balloon, so you will apply same amount of forces from both the sides. It will change the shape of the object, yes or no? Forces are balanced, but the shape is getting changed. So only thing that can be happened with the balance forces is that they can change the shape. Clear? Saad, what happened here? Feeling tired a little bit? No, chalo, ठीक है. Okay, clear everyone?
Yes.
ठीक है.
Yes, sir.
Okay. Forces. Produce motion. Stationary body. Or stop a moving body. However, change the shape of it. बोलो clear हुआ सबको ये बच्चों? Please let me know once. Right? Just
Yes, sir. Yes, sir.
okay. So now let's talk about, now we have done the balanced forces. Now it's time for the unbalanced force. Okay. Unbalanced force. So it means that if resultant of all the forces are not equals to 0. Okay. It's not 0, then the forces are unbalanced forces. Clear, everyone?
Yes, sir.
Without you, Sivo?
Yes, sir.
So as you can see that the force are not, it means that the resultant, it means that if we add all the forces, that is not equal to 0. It means that some amount of force is left. So it means that it can produce a motion as well as the force can stop a moving body as well. Okay? So unbalanced forces are responsible for making the object in motion and stopping, basically stopping a moving object. Clear, everyone? What happened? Clear way? Nahi.
Yes, sir. Yes.
Sara, Anam, Arham, Hanan, राफे, साद,
Yes, sir.
भारती,
Yes,
अरहान,
sir.
चलो ठीक है। जब तक नाम नहीं लो आप लोगों को, आप यस नहीं बोलते। चलो कोई बात नहीं, ठीक है। क्लियर सबको ये यहाँ तक? ठीक है। सो इट मींस दैट अनबैलेंस्ड फोर्सेस आर रिस्पांसिबल फॉर द मोशन इन एन ऑब्जेक्ट, ठीक है, ऑफ अ स्टेशनरी बॉडी, ठीक है। So देखो, so if we take an example, suppose a car is standing, a car is basically is in rest, it is not moving at all. So but there is a rickshaw that need to be passed by through the car. So if you have, if suppose that there is no key of the car, so like what will happen, like in India it's very usual, so two people will come out from their building and they will push the car in the backward direction so that the other vehicles can pass out. Have you seen this thing? Like this is very
Yes, sir.
usual in India. Okay, so that's why, so this is a kind of you can say unbalanced force. It means that when the car was at rest, so the forces were balanced, right? So when they push, when the two-person push the car in the another direction, so their push overcome the frictional force. So that's why the car started to move. Say yes or no?
Yes, sir.
ठीक है? So
Yes,
clear ये बात सबको?
Yes, sir.
Chalo, that's good. Okay. So to move a stationary object, we have to push it with a greater force than the opposing force of friction. So if that suppose if force is calculated in Newton, so 10 Newton of frictional force is present between the tires and the ground. Okay. I need to I need to do what? I need to basically I need to basically apply some force that should be greater than 10 so that the car start to move. Okay. So that's why the motion, basically the amount of force should be greater than the opposing force of friction. Okay. Friction move a stationary object. Clear? Yes, I say yes or no at least, Michu.
Yes.
Yes, sir.
Sure, that's good. That's good. Sure, that's good. Acha, what will happen? Suppose that if there is no force of friction, suppose that a bicycle is moving on the road, right? So if there is no force of friction, okay, and so what will happen if there is no force of friction? If the cycle is moving, okay, and we have not reduced the velocity of the cycle, and it is moving continuously. Suppose there is no force of friction between the ground and the tire, what will happen?
Cycle will slip.
Check your first case, cycle will slip. What happens?
It won't move.
Huh?
It won't move. It will stay in the same place.
What are you saying, Saad?
It will stay in the same place, the cycle.
The same case, it means that it will slip.
Yes.
ठीक. Anam, Bharti,
So it
Anand.
will keep on moving, it won't stop.
अच्छा ठीक है. Bharti said that it will keep moving, it will not stop. ठीक है. Anam, Anand,
Sir, no matter how much hard we try, we cannot get it to stay still.
what
Keep on
it will
keep on moving.
keep on moving. Anam, what you were saying, dear? Actually, I was not able to hear you clearly.
Sir, no matter how hard we try, we cannot try to get it still.
ठीक है. Okay, anyone? Arham, Haider, Sara, Rafe. अच्छा, I got one answer in the chat. It will not stop. ठीक है, Haider. Sara?
It will move, it will keep on moving.
It will keep on moving. ठीक है. Rafe?
So when a car starts, it's the tire starts to slip very fast if the accelerator is pressed too hard.
Okay. Sure, that's good. All basically the scenario that you have given to me is absolutely right. So both the scenarios are possible. So the first scenario is that if there is no force of friction, the tire will slip away on the road. Okay. Second scenario is that if there is no force of friction and if the bicycle is moving continuously, so and there is no force of friction, so it will keep on moving infinitely. There is constantly. You are saying something?
So constant velocity.
हाँ, constant velocity होगी ना डियो. ठीक है. So is this clear to all of you, बच्चों? So both the scenarios are possible. Is the first is the tires will slip. Second scenario is that it will keep on moving. Okay. So if there is no force of, so that's why force of friction is very is very important in our day-to-day life. Okay. Okay. So that's happened. Okay, Anam. So you are telling me in the start of the class that you have doubts. So please tell me which doubt you have. Please share that doubt in the chat so that I can take this, paste it on the screen, and we can discuss it. चलिए बच्चों, आपके लिए क्वेश्चन आ रहा है. Anam is having a one doubt. ठीक है. So I will give you 2 minutes to solve that question. Okay, I will give you the chance to all of you. So it's a request to all of you to at least try, and then we'll discuss it. ठीक है. ठीक है ना. Everyone, please solve this question. Which one, Anam? 13th one?
It would be better if you could just do both of them.
अच्छा, ठीक है. No worries. ठीक है बच्चों. So पहले आप 13th क्वेश्चन करो। Anyone, any answer? Any answer from anybody, बच्चों? Please let me know once. Last minute, बच्चों.
I sent you the solution, sir.
ठीक ठीक. ओके अरहान, ठीक है. So -2 meter per second, Arhan. So the question is not asking -2 meter per second. It is asking that what should be the graph and how it will change. चलो ठीक है, let's discuss. ठीक है बच्चों, everyone please look at the screen. ठीक, चलो. So the question is saying that how will the equations of motion for an object moving with uniform velocity change? अच्छा ठीक है, first of all let's write down all the equations. ठीक है. V equals to U plus AT. ठीक है. Second is, sorry, S is equals to UT plus half AT square. ठीक है. Third is V square minus U square is equals to 2AS. ठीक है. So these are the three equations of motion. So when do we use these equations? What is the minimum? What is the basic condition to use these equations?